Good day, grade 9s. Actually, it's good morning because you guys are going to have this lesson at 8 in the morning. How are you guys doing today? Today we are looking at behavior of gases. Remember in the previous lesson we were talking about hydrostatic pressure, pressure in fluids, how that pressure can be transmitted through fluids. So now when we're still dealing with fluids and dealing with gases, we're going to look at the behavior of gases. And what we mainly look at is the relationship between temperature and pressure, the relationship between pressure and volume, and the relationship between pressure and temperature. Okay, effects also of altitude on pressure. Okay, so that's what we're going to look at. I'm going to just explain quickly the notes that we have on our PDF so that you guys can have clarity on maybe some issues that might be a bit difficult. So just have a look at the objectives and see if there are words that you'd want to maybe look for in your dictionary or in your textbook. Right, so the first part, which says behavior of gases and gas pressure, effectively just shows us the properties of a gas. I hope we know what a gas is. We know when we talk about gases, we have states of matter, with 3 states of matter in the solid state, liquid state, and the gaseous state. And we know that gases have no definite volume or shape, right? If it's not in a container, gas just flows and it just moves everywhere. But then when you enclose it in a particular container, it will take whatever shape of the container in which you have placed it, and the volume of whatever container in which you have placed it also. And we know that when these gas particles, because gas is having particles such as oxygen, or if it's not oxygen gas, or if it's nitrogen gas, or if it's hydrogen gas, these are actually particles of the atoms of hydrogen, even though they are invisible and we can't see them. They're actually moving in that container. And when you fill up a container, these particles are actually bumping against the walls of the container. And when they bump against the walls of the container, that's when you actually start seeing the container expanding, if maybe temperature is being increased, or if the volume is actually being reduced. So we'll talk about now the relationship between these 3 factors. We would want to see how volume, temperature, and pressure affect the behavior of a gas. Because gases are not always going to behave in the same way. I'll just slow down a bit and just try and remind you of this. We are talking about how we have particles in the gaseous state. And these particles which are in the gaseous state, there is a way we talk about how they can move. They can move anywhere where they want to, right? Because the forces of attraction between them are so small. But the behavior of these gases, if we have a gas during a hot day, the behavior of the particles of that gas cannot be the same as the behavior of the particles of that gas during a cold day. A hot day and a cold day are going to be different. So you will find that temperature actually affects the behavior of a gas, right? Temperature actually affects the behavior of a gas. So just read, please, these first 2 points on the relationship between pressure and volume, right? And also the relationship between pressure and temperature. Just read them briefly, and I will explain them just now. Okay, so now we have a point here, and it's showing us that volume and pressure are indirectly proportional. Indirectly proportional. I hope you know what indirect proportion is. Indirect proportion refers to a situation where if one quantity is increasing, then the other quantity is decreasing. Just imagine, maybe if I can give a simple example of if you are driving and you are driving from Omalala and you're going to Ondangwa, okay? If you increase the speed of the vehicle in which you're traveling, that means the time it takes you to get to Ondangwa is going to be less, right? So as you increase the speed of the vehicle, the time it takes for you to get to Ondangwa reduces. So we would say the relationship between speed and time, right, velocity and time, is actually indirectly proportional. And if you were to reduce your speed, it will take you more time. I hope you understand that. This is the same when we look at volume and pressure. If you look at pressure and at volume, pressure increases when volume decreases. Or actually, we will say volume will decrease if you increase. If you increase pressure, right? If you increase pressure, the volume will decrease, right? If you increase pressure, the volume will decrease. And how can you increase the pressure of a container? Try and think of a container and try to think of how you can increase its pressure, right? You can increase its pressure by reducing the amount of space. Just think of a container and maybe you are putting something else in that container, right? I was going to give an example of a piston. Let me see if I have a piston on this page. No, I'm not having a piston here. Okay, guys, I'm going to use this diagram of a hydraulic jack to try and explain, for those of you, like in the previous lesson, we talked about a hydraulic jack as an example of how you can actually use applications of pressure to say when you can move a bigger load using a smaller effort. But what the point I was giving was, if you want to reduce the pressure, or if you actually want to increase the pressure, think of this as a piston. This is a piston. This is what we call a piston. So this is a container. No, please remove that. So this is a container, and then that piston, if it was closed here, as you are moving this piston down, where it says piston area A here, if you push it down, it means that you are actually increasing the pressure inside of this system, right? You are increasing the pressure inside of that container. So when you increase the pressure, but observe that the volume, the space, because as we move down, this is like almost like a stopper, like a cork. As you move it down, right, you reduce the space inside of this container, which means that you reduce the volume. So it therefore applies that when you increase the pressure, you reduce the volume. When you increase the pressure, you reduce the volume. Therefore, whenever you have a container and you are going to squash it, right, therefore by increasing its pressure, you're actually reducing its volume and the space in which the particles that are in there can occupy. And what's going to happen to the things that are inside that container? What happens when you squeeze a bottle and you squeeze it real tight? It will pop, right? It will pop because the particles that are inside have to escape because they have to occupy a certain amount of space, and now you have reduced that space. If we look at the relationship now between pressure and temperature, so for those, I'll just put this on the screen again. For those who didn't see last week, this is a hydraulic jack. This is a hydraulic jack, and this is a hydraulic system. Remember, we're talking about hydrostatic pressure. This is how the brake system in your cars work. You step on the brakes, right? You step on the brakes, they push a cylinder, and then fluid moves, brake fluid, you call it brake fluid, and it goes, and it causes the brakes to then go onto the vehicle, right? Cylinder of rear left wheel or cylinder of right wheel. But the brake fluid is that what then pushes the brake pads, and they cause your vehicle to stop. So for those who didn't understand that, I will just have this move through the page, and then you can then pause the page and just have a read on how it works. It's a very simple and a very interesting concept. Okay? So pressure and temperature are now, we said volume and pressure are indirectly proportional, but pressure and temperature are directly proportional. If you increase the temperature, pressure will also increase, right? So that direct proportion is just that as one factor increases, another factor also increases. Directly proportional. Directly proportional. And gas pressure is measured with a myometer. I hope you guys, I hope you have your textbooks as well there at home. I'm sitting in your room. I see that most of your textbooks are not here anymore. So I'm hoping you have them with you, and you can look at the apparatus that we use to measure atmospheric pressure. Okay? So let's move on to atmospheric pressure. You can read what atmospheric pressure is, but that's basically the pressure that's acting on us right now, right? Because of the weight of air in the atmosphere. So there's a lot of pressure that's acting on us right now. We just cannot feel it because we are now used to it. Okay? Otherwise, if we were not adapted to these conditions on this planet, it would actually squeeze us and pop us, and we would burst. We would burst. But because we have grown up in it, the pressure, we are actually used to it now. So just have a read on what atmospheric pressure is, and you can pause the video for maybe just a minute or two to just go back and just try to assimilate what I've been saying. Okay, so when we do measurements, you saw previously I said the manometer. When we're measuring atmospheric pressure, we use what we call a barometer, right? We use what we call a barometer, and we can also use a cylinder that has mercury in a dish, okay? And this mercury moves up an inverted cylinder, a glass tube, okay? Moves up this tube. Let me just open. All right, so as we are moving this, as we are using this mercury barometer, you will find that it works by a process where you see that there is mercury in the dish there. So if pressure is acting down on it, it will force the liquid to then move up the container, right, the glass tube. And this glass tube, you see where it says 760 millimeters, it has graduations, little lines like on a ruler, right, like on a ruler. And that then tells you what the pressure is on a particular day. So the pressure using a mercury barometer is measured in what we call mmHg. What is mm? Ag is silver. mmHg, millimeters of mercury, right? Millimeters of mercury. That's the unit when you are using an aneroid barometer. An aneroid barometer. And so we also use a barometer, or we can use a manometer. Then we will also talk about in the lesson itself. In the lesson itself, we will talk about the effects of pressure. You know, effects of pressure and how you have different pressures at sea level and at altitude. At altitude, either at altitude when you are just there at 0 meters above sea level. I hope you guys know what altitude is, right? Altitude, it says here, air is denser at sea level, at the coast. So if you go to the coast, to Walvis Bay, I don't know if the coast is there, Walvis Bay, Swakopmund, those areas, their pressure, the amount of air pressure there is much more as opposed to what it is here in the north, right? So we'll talk about that also in the lesson, right? But on this PDF, please make sure that you read the entire PDF, and I will explain the remaining concepts in the lesson. I don't want this video to be too long. So thank you guys very much for watching, right? Just make sure that you look at these diagrams. You look at this diagram for a mercury barometer. This is just liquid pressure. Then a manometer. This is what a manometer looks like. It's connected to a gas supply. It's effectively a U-tube. A U-tube. You can also read. That's why they are not here. You can actually read them. You can pause the video and you can read them also. So thank you very much, guys, for watching this video. This is Marshall AC Candiado. Goodbye.